continuing with our notes for our first day of trig. We are looking at dividing we call this a unit circle. We'll talk more about that in a couple days. But dividing it up into degrees and radians. We always start here, positive x-axis. What would that be in radians? 0. It's 0 degrees and 0 radians. Okay? Now, there's no symbol for radians. You can write, you know, put RAD after it to remind you that you're in radians, but there is no real symbol for it. That means it's critical if you are giving an answer in degrees that you put the degree symbol. Because if you're talking about a 45-degree angle and you just write 45, it's going to be interpreted as 45 radians, which is completely different than 45 degrees. Okay, so for the degrees, make sure you put the degree symbol on there. All right, we want to cut this top half into 4 parts. The whole top gives us all the way to how many degrees? 180 degrees. Okay, if we cut it in half, we're at what? 90 degrees. Okay, if we cut each of those in half, we've made what kind of angles? 45. So really, when they're talking about dividing it up into 4 chunks, each of those chunks is 45 degrees. Yes? So you can count by 45s. This would be 45 degrees. Add another 45, we're at 90. Add another 45, we're at 135 degrees. And add another 45, we're at 180. And we could go all the way around the circle doing that. Okay? We're just going to focus on the top half. In radians, we said we're starting with 0 radians. Again, we have pi gets us halfway around the circle. Okay, 180 degrees is 1 pi. We want to cut that in half. This would be pi over 2. Cutting each of those in halves, we get what? Pi over 4. If we cut a half in half, we're at a 4th. Okay, and again, use that denominator. We're cutting them into 4s. We're going to get pi over 4 pieces. Okay, so this first one is 1 pi over 4. Then we'd have 2/4 or 1/2. Then we're going to have 3/4 of pi, and then 4/4 or 1 pi. Does that make sense? And again, we could keep counting. This would be 5/4, 6/4, 7/4, and then we're back to 8/4 or 2 pi, full way around the circle. Okay? All right, going in sixths. Again, we start with 0. 1, 2, 3, 4, 5, 6. We've cut it into 6 chunks. We said all the way around to that half mark is 180 degrees. If we cut that into 6 chunks, each chunk is 30 degrees. So counting in 30s, we've got 30 degrees, 60 degrees, 90 degrees, 120, 150, and then 180. Okay? In radians, we just took 1 pi, the top half of our circle, we cut it into 6 chunks. Each of those chunks represents pi over 6, or 1/6 of pi. So we're at 0 radians. We're at 1/6. 2/6 would reduce to 1/3. 3/6 reduces to 1/2. All right, then we're at 4/6, which would be 2/3. And then 5/6. And then 6/6, which is 1 pi. Okay? Questions about doing that? All right. The last thing we're going to talk about is coterminal angles. It says 2 angles with the same initial side and terminal side, but different blank are coterminal angles. Talk at your tables. What would your guess be? They have the same initial and terminal side, but different. Any ideas? Different rotations. Remember how we talked about positive and negative rotations? Marking off an angle in a positive direction or a negative direction. That's one way to get to the same spot, but have a different rotation. What would happen if we started on the positive x-axis and we just kept spinning? Could I land there? That's a different angle than just going from here to here, right? I went around and around and around. I'm still landing in the same spot. They'd be considered coterminal angles. Okay? They have different rotation and mounts, but they start and end in the same spot. So to find them, we simply add full circles or subtract full circles. Okay? A full circle is either 360 degrees or 2 pi, depending on which kind of notation you're using. All right, so for our example, it says, assume the following angles are in standard position, meaning we're starting at that positive x-axis. Okay? Find a positive angle. I can create a negative angle as well, but in this case, we're asking for a positive angle less than a full circle, less than 360 degrees or 2 pi. That would be coterminal to the given angle. Okay? So, I want you to picture 420 degrees. Is that more than a full rotation? All right. If we add another 360 degrees, we're making it too big, right? They want an angle that's between 0 and 360 degrees. We can't keep adding to it. But we could subtract 360. So if I subtract 360, what do we get? 60 degrees. All right. I want you to picture the initial one was 420 degrees. If I go one full circle, I've used up 360 degrees. Correct? And we're saying that 420 is 60 degrees past that. So we're up here. Yes? The coterminal angle would just be the 60-degree angle. So instead of spinning all the way around and continuing, we're just going from 0 to 60. Does that make sense? Okay. Negative 120. What does the negative mean? We're going clockwise instead of counterclockwise. All right, so let's picture where that angle lands. We're starting here, and we're going negative 120 degrees. Well, if I go to here, I've gone how far? That's negative 90. So I need how much more? Another 30 degrees? All right, so I'm at about here. Yes? Okay, so that's negative 120 degrees. What would a coterminal angle be that's positive? Do I want to keep subtracting 360? Or that's going to make it too big, right? In a negative direction? All right. So can I add 360? What do I get if I add 360 to negative 120? I get 240. That is a positive angle, right? Less than a full circle. So what we've really done is we've said, let's go from here to there in a positive direction. It's still a coterminal angle. I'm still landing in the same exact spot. I just have a different rotation to get there. Okay? All right. I'm going to pause the recording. I want you guys to try the next one. All right. Let's check your work. Where is a 750-degree angle? Going around once is 360. Going around a second time gets me 720. So I have to go another 30. Yes? That's the initial angle. Around twice plus an extra 30 degrees. What's the coterminal? Just a 30-degree angle. Okay? Does that make sense? We're still starting and ending in the same spot. We're just skipping all the spins. Algebraically, I can show that by subtracting 360. That left me 390, which was still bigger than a full circle, and they want an angle less than 360. So we would subtract it again to get down to our 30 degrees. Okay? All right. At the beginning, I said we can find negative angles as well. And sometimes you're asked to find a positive and a negative angle that are coterminal. So for this one, could I subtract another 360? That would put me in the negative region, right? That would work. Or I could just picture going around in a negative direction. Does that make sense? That would get me the same answer. Okay. The last three are in what kind of measurements? These are in radians. How do we know? Okay. And that's the most common answer. There's a pi in there. Okay? I could say I have an angle that's pi degrees. How big is pi? 3.14. So I'm basically saying I have an angle that's 3.14 degrees, right? Just because there's a pi in there doesn't mean it's a radian. The fact that there's no degree symbol is what tells you it's a radian. I can tell you I have an angle that is 2 radians. There's no pi in there, but there's no degree symbol, which means I'm talking about radians. Does that make sense? Okay. So we have an angle that is 17 pi over 6. So can you visualize that circle above in your notes where we divided it into 6? We had the top half giving us 6 chunks, right? If we continue that on the bottom half of our circle, we'd have how many chunks? 12. Is 12/6 pi the same as 2 pi? So when we talk about adding and subtracting full rotations, full circles, use whatever denominator you have and just know that you need 2 pi of those. So if I'm dealing with a denominator of 5, I'm going to think of a full circle as 10/5. If I have a denominator that's 7, I'm going to think of cutting it and saying that's 14/7 would be a full circle. Okay? So we have 17/6 pi. We need to take off chunks of what? Full circles would be how many sixths? A full circle. 12/6. So I'm going to start subtracting 12/6 until I get down to something that's less than a full rotation. Does that make sense? Okay. So my idea here is that I'm going to subtract 2 pi. We're thinking of that in terms of sixths, so I'm subtracting 12/6 pi, which gets me an angle that is 5 pi over 6, or 5/6 pi. Okay? I want you to draw both the 17/6 and the 5/6. What would it look like? So we start here. We said one full rotation was 12/6, right? Do I want to go another 6/6? No, I'm just shy of that, right? I only need another 5/6. So I'm past 3/6, but I'm not all the way to 6/6. I'm 1 pi 6 short of getting all the way over to 180. Okay? So that's the initial one. That's the 17/6. This would be the 5/6 pi. Okay? All right. How about the next one? We have an angle that is negative pi over 12. Now remember, that means we are taking 1 pi, the top half of our circle, and cutting it into 12 pieces. So a full circle is 24 of those. Does that make sense? Do I want to add or subtract 24/12? I need to add, right? Because I need to get it to be a positive answer. All right. So negative 1/12 plus 24/12 would be 23/12. So my coterminal angle is 23/12 pi. Okay? What would that look like? My initial one is going in a negative direction, right? I have to picture this bottom half of my circle being cut into 12 chunks, right? Or one quadrant being cut into 6 chunks. So it's not a very big angle, right? My positive angle is going from here to there. Does that make sense? Okay. All right, I'm going to pause the recording. You guys try the next one. All right, 21/3. So we're thinking of cutting the top half of our circle into 3 pieces. That means a full circle would be 6 pieces? 6/3? Okay, so we need to start subtracting 6/3 of pi. So we've got 22/3. We're going to subtract 6/3, or 2 pi, 1 full rotation. That puts me at 16 pi over 3. Still too big, right? I need to get it down under 2 pi or under 6/3. So I'm going to take 16/3. I'm going to subtract another full circle. I'm down to 10/3. Is that small enough? No. So again, we've got 10/3 pi. We're going to subtract a full rotation. We're down to 4/3 pi. Is that okay? Yes, because 1 full rotation, 2 pi is the same as 6/3. We just have to be under 6. So we have an angle that's 4/3 pi. How many rotations did we subtract? 3 full rotations, right? So if I'm counting, or if I'm trying to draw an angle that's 22/3 of pi, here's 0. This would be 6. This would be 12. This would be 18. How many more do I need? From 18 to 22. 4/3. Halfway is 3/3, right? I need 1 more third. I'm actually down here more. Yes? Okay, so our coterminal one is from here to there. Does that make sense? Okay.